a continuation of the previous video. The line separates W transpose X equal to 0, divides the inputs into two groups. And for the inputs that produce 1, the angle is what? This P1, P2, P3 produce output as 1. These inputs produce output as 1. For those inputs, the angle between the W and those inputs will be what? Less than 90 degree. And for those inputs which produce output as 0, the angle between the W and the X, those inputs, will be greater than 90 degree. Keep that in mind. Now, how the perceptron learning algorithm works? P, the inputs, those inputs with label 1, that's this the inputs with which produce the output as 1, and for those N are the inputs which produce the output as 0. So initialize the W randomly. This convergence will do while or the convergence do pick random X belong to P union N. If X belong to P, that is those it belong to the input set of inputs with label 1. So W dot X, that is W transpose X over the dot product is less than 0, then what? W equal to W plus X. N, for the other case X belong to N, W dot X, that's the dot product is greater than or equal to 0, then W equal to W minus X. N. How this algorithm works? If for X belong to P, W dot X is what? Less than 0. Less than 0. If for P means obviously it has to be what? Greater than 0. If that W dot X is less than 0, then it means what? The angle alpha between the X and the current versus is what? Greater than 90. Actually, we want them to be less than 90 degree. For P1, P2, P3, it has to be less than 90 degree. So, what I have to do? What we have to do? What? W equal to W plus X. So, W equal to W plus X. For this, when you find a cos of this, what will actually the new angle will always be less than the previous angle. When you W equal to W plus, when you go in the other way, that is W minus X, the new angle will be less than the previous angle. Here W plus will be greater than. Just you have worked it out. So what about non-Boolean functions, real inputs? Do we always need to encode the threshold, or we can learn it? Are all inputs equal? What if we want to assign more weights to some? What about functions which are not linearly separable? So real valued inputs are allowed in perceptron. These are the questions. For those questions, these are the answers. Real valued inputs are allowed in perceptron. In MP neural, only Boolean inputs are allowed. Do we always need to encode the threshold? No, we can learn the threshold. Are all inputs equal? What if we want to assign more weights or importance to some inputs? A perceptron allows weights to be assigned to inputs. What about functions which are not linearly separable? Not possible with a single perceptron. So with a single perceptron can handle only linear separable function, just like MP neuron. Okay. Now XOR problem and we send XOR problem. XOR is the two tables 0 0 1 0 1 0 1 or 0 1 1 1 1 1. Just you for perceptron. So this will be less than 0 because the output is 0, greater than or equal to 0 because the output is 1, greater than or equal to 0, output is 1, since the output is 1, so less than or equal to 0 because since the output is 0. You have this W2 is greater than minus W1 is greater than W2. Now the fourth condition contradicts the second and the third. So no way we can find a solution for this set of inequalities. Just look at this diagram. So where we can draw a line which can separate the input into two groups? No way we can draw. Can I draw like this? No, I can't draw like this. Okay, I can draw. No way I can draw. Okay. Now we can see inputs here. Instead of so most real world is not really separate, always contains some outliers. What is outliers? These are the outliers. So this is majority of them are blue. So some of them don't fall in this group. These three red are outliers. And for this group, this group contains most of them are red. These three blue are outliers. Can I draw a line like this? Can I draw a line which separate them into two groups? Yes, I can draw. Still, I am having some error. I can tolerate with this error. Tolerate in the sense that I will have some error. I can work with this error. Okay. Now I can draw a line. Strictly speaking, I cannot separate them into two groups, but with some error I can model it. What about this? No way I can draw a line which divide them into two groups. Okay, fine. We need computational unique models which can deal with such data. While a single perceptron cannot deal with such data, we will show that a network of perceptrons can indeed deal with such data. Network of perceptron is a multi-layer perceptron. This is a network of perceptron. Here, this is the input layer, S1, S2, S3, S4. These are the hidden layer, and we have the output. This network contains three layers. The layer containing the inputs X1, X2 is the input. Middle layer containing the four perceptron is called the hidden layer. Here these four are perceptron. Each one is a perceptron. The final layer containing one neuron. Only one neuron is there. Is the output layer. The output of the four perceptron, the hidden layer, are denoted by H1, H2, S3, S4. The red and the blue edges are called layer 1 edges, layer 1 bytes. W1, W2, W3, W4 are called layer 2 bytes. W1, W2, W3 are layer 2 bytes. H1, H2, S4 are the outputs. Red and blue are the layer 1 bytes. Red and blue are layer 1. This is the layer 1 bytes. Red indicates what? -1, and blue indicates what? +1. This is the convention followed here, and bias is 2 here. Here we can work out red is -1 and blue is what? +1, and bias is 2. Now XOR let us see whether we can solve the XOR problem with a multi-layer perceptron. 0 0 0. This is the output for XOR. What is H1, H2, H3? Let us see the output of each perceptron. So I said red is what? -1, and blue is what? +1. So X1, X2, you treat 0 as -1 and 1 as -1. The input 0 as -1. So 0, 0. So -1, -1. So -1 into -1. Red is -1. So -1 into -1 and -1 into -1. So I will get what? -1 into -1 is +1, -1 into -1 is +1. So 1 + 1 is 2. So the bias is 2. So H1 will be activated. So the output is 1 there. What about H2? H2 is we have red and blue here. So what is H2? H2 is for 0 0. So 0 0. So 0 is, I said 0 is -1. 0 is 0 treated as -1. 0 0 -1 -1. So -1 -1 is +1. And -1 into blue, here we have blue here. So -1 into +1 is what? -1. So 1 minus 1 is what? 0. The bias is what? 2. So the output will be 0. In this way we can work it out. So we will get the complete table. So what is W1? The summation here. So H1 alone is 1. So what I will get? I will get W1. Here H2 alone is 1. So I will get W2 here. Here W2. Here I will get W4. So what is this in the following four conditions? W1 is less than W0. Why? W1 is less than W0 because what is this? Left hand. So this the output will be fire. Fire means what? The output will be 1. So this condition will be greater than or equal to 0. If it's not firing means less than W0. So this is the left hand side. So W1 is what? W is less than W0. And for this W2, this is fired here. This is activated. So W2 is greater than or equal to W0. For W2 is greater than or equal to W0 because the output is 1 there. Here W4 output is not activated. The output is 0 only. So W4 is less than W0. So unlike before, there is no contradiction here. the set of inequalities can be satisfied. It's very clear. Inequalities are very clear. So why? Because the for each input, for each combination of input, only one perceptron gets activated. All other perceptron in the Indian case are deactivated. Each WI is now responsible for one of the 4 possible inputs and can be adjusted to get the desired output for that input. Again, each of the 8 perceptrons. So ideally, how do you compute the number of perceptrons, number of neurons in the Indian layer? It depends on the number of inputs. If I have 3 inputs, then I have 2 power 3. 2 power 3. The number of neurons in the Indian layer will be 2 power n. So here since I am having 3 inputs, so I will have what? 8 perceptrons. So each of the 8 the second layer is responsible for one of the inputs and can be adjusted to produce the desired output. So XOR problem is solved here. So a multi-layer perceptron can realize any Boolean function. So summary, the network of the form that we just saw containing an input, the output, and one or more hidden layers are called multi-layer perceptrons. In short, we can say MLP. More appropriate terminology would be multi-layer network of neurons, but MLP is the most commonly used name. The theorem just we saw gives us the representation power of MLP with a single hidden layer, which tells that MLP with a single hidden layer can represent any Boolean function. It can be OR, AND, XOR, any Boolean function. And MLP, a multi-layer network of neurons, multi-layer perceptron with a single layer. With a single layer can represent what? Any Boolean function. These are the references I made.